All right, so here we want to evaluate the integral of 1 over 5 minus x to the 1/3 power. Now, this is going to be an improper integral. And the reason why is because our first step in determining what we should do with our integral, evaluate the function, right, the integrand. If we plug in 5, right, one of our bounds here, we're going to get a 0 on the bottom, which means that this is going to be a 1 over 0, and we're not going to know what's going to happen to this function as right, as we get a hole there. Right? There's a discontinuity at 5, which means that we have to apply our next step, right, for the first step of dealing with improper integrals. We have to make a parameter for 5 so that we can evaluate what happens to the integral as we go to 5. So we're looking at the limit as t goes to 5 of the integral from 0 to 5, 1 over 5 minus x, 1 over 3 dx. The integral for this one is actually pretty easy. If you have a u is equal to 5 minus x, then du is equal to negative dx. Alright, then we're just going to get a negative 1 over u du. So this will become the limit as t goes to 5. Right, and remember we're going, we're evaluating in this direction, right? So we're coming from the left when we're going right. So we're going to take this limit as 5 as t goes to 5 from the left. So we pull out the negative sign, then we go from 0 to t. Sorry, this one should have been a t. Then we go 1 over u du. Right, we already took the negative sign out here. Now, this one is just the natural, sorry, not the natural log. This one would be 1 over 3. Alright, so this one we use our power rules. So we have the limit as t goes to 5, 0 to 5, u to the negative 1/3 power du. Right, using the power rules, this is going to go to plus 3 over 3, right? This is going to go to 2 over 3. Then we're going to divide by 2 over 3, so we're going to multiply by 3 over 2. So we're going to get negative limit as t goes to 5, right, of u to the 2 over 3 times the 3 over 2 from 0 to t, right? And then we evaluate our bounds. And so we're going to get negative limit t goes to 5, left, 3 over 2. And remember to plug in your t's. So we have 5 minus t minus, right, to the 2/3 power. 5 minus 0 to the 2/3 power. Now, normally, I would include the right, the limit here, but because there's no t in this part of the function, right, the limit's not going to affect it. It's just going to be a constant. And in this case, it's going to be minus 5 to the 2/3 power. Now, if we look at this one, if we apply the limit here, it's going to affect it. And if we apply the limit inside, right, inside here, we get 3 over 2. Right, limit t goes to 5 of, right, 5 minus t to the 2/3 power. Right, this is going to evaluate to 0. We're going to get 5 minus 5. It'll be 0. 3 over 2, right, times 0 minus, oh, and I forgot the 3 over 2 here. 3 over 2 times 5 to the 2/3 power. Right, and don't forget we had to carry out the negative from earlier. Right, so whenever we do that, we're going to get a positive 3 over 2 times 5 to the 2/3 power. And that'll be the final answer. So there, the integral is pretty easy. We just had to evaluate the limit here, and it's this one ends up going to 0, and we couldn't forget the negative sign here. Otherwise, we'd end up reversing the sign. So this one, pretty simple, easy to figure out where the holes are and what to do with it. Right, we're going to 5. That's one of our continuity errors because our function at 5 here is going to be undefined. So hopefully that'll help you understand a little better what we mean whenever we say we want to make a parameter out of the boundary where there is a discontinuity.